All right, again, welcome to class. Hope that you were able to watch the 6.3 intro video. We're going to be working on 3 different examples here in our class today. And so based on what you learned in the video, I'm going to hope, and of course based on your experience in the past, I'm going to hope that you can handle some of these, hopefully all of them. And so I'm going to encourage you at this point to look at your notes, find this example number 4. I want you guys to work together, work on your own, compare answers and notes, and see if you can complete this. So go ahead and push pause on the video, and let's let everybody give it a shot. And when you're ready, push play, and you can watch the solution. We'll also probably briefly discuss how points would be awarded, most likely in a situation like this. All right, so we are supposed to, the directions up above say we're supposed to find the particular solution based on the differential equation and the initial condition. And so whenever we're in these situations, the first thing we want to do is we want to work to separate the variables. So the first thing I'm going to do is add 5xy to both sides. That would give me dy dx is equal to 5xy. And then I need to do a little bit of multiplication and division to fully separate the variables. I think once I do that, I'm going to get dy over y is equal to 5x dx. So at this point, I have separated the variables, and I would have earned my first point if this were a quiz or a test question. If I did not show that step, where I've separated the variables, I in all likelihood would earn no points. So this is a very important step for us to make sure we show on our work. All right, once we've done that, once we've separated the variables, we are going to find the antiderivatives of both sides. And so that's going to give me natural log of absolute value of y is equal to 5/2 x squared plus c. So at this point, I found my antiderivatives, and I've included my plus c. At this point, on this particular step, I'd either earn 1 or 2 points, depending on how the rubric would award points for the antiderivatives. And then I need to go one more step here to kind of fully earn the point for the c. But at this point, I've got my differential equation anti-differentiated, and I'm going to work to find my c value. And the way that I find my c value, of course, is to use my initial condition. So this is saying that when x is -2, y is 1. So I'm going to plug in right now, and this is going to give me ln of absolute value of 1 equals 5/2 times x squared, or excuse me, times 2 squared. Yeah, how about -2 squared? There we go, plus c. All right, so I'm going to just continue on and do a little bit of algebra to figure out what the c value is. ln of 1 is 0. And let's see here, 5/2 of 4 is 10. And then plus c. So I'd subtract 10 from both sides. I get -10 is equal to c. And so my particular solution to this differential equation is, we're almost there. We'd have ln of absolute value of y is equal to 5/2 x squared minus 10. Now my final steps are going to be to get the y by itself. So I'm going to go e to both sides. Once I do that, I'm going to get absolute value of y equals e to the 5/2 x squared minus 10. And then the last thing I got to do is I've got to evaluate the absolute value. And this is where we need to remember back to our initial condition, which is back here. So when I plugged in the initial condition, we want to ask ourselves if the absolute values were necessary to turn a negative over into a positive as we evaluate the absolute values. And of course, in this case, the answer is no. The absolute values did not have that effect because the input was already positive. And so as we evaluate absolute value of y, we would take the positive side, and we would say y equals e to the 5/2 x squared minus 10. That would be the particular solution to our differential equation. All right, so again, as far as the points go, I'll just kind of write this in here in a different color. So I would earn my first point right here by separating the variables. I would imagine probably you might earn 2 points for this step, 1 point for each antiderivative. It's possible you might only earn 1, but at least 1, possibly 2. And then having the plus c and then applying the initial condition would actually be worth point number 4 or 3, depending how this worked out. And then your final solution to your diff EQ would be worth 1 point. So we'd probably be looking at 4 or 5 point question here. Now please note the importance of this step right here, where you show the plug-in, where you plugged in the initial condition into the appropriate places. Make sure you do show that step. Don't skip steps and do arithmetic in your head. Show where you have plugged in that initial condition. Beyond that, of course, you can do arithmetic fairly quickly, like I did, but you want to show that step where you've applied that initial condition. All right, let's move on to number 5. Give this one a try, and once again, feel free to pause the video and try it, and then play the video once you're ready to see the solution. All right, hope number 5 went well for you. Here is a solution to number 5. Once again, if we're trying to find this particular solution, we want to first show our separation of variables. If I'm going to show my separation of variables, I think I'm going to show something like this. I think I'll divide both sides by y. That would give me dy over y. I'm going to multiply both sides then by dx. That would give me on the right side 3 over x dx. You might have divided both sides by 3y possibly. There's nothing wrong with that. My thought on the matter is, I know in the end I'm going to be trying to solve for y, so the fewer things that I include with the y, the better. It's going to make the end easier, and so that's why I left the 3 over there. It doesn't have to be that way, but that's why I did what I did. All right, so once you've separated the variables, we're going to find antiderivatives, so I'm going to anti-differentiate both sides. That'll give me natural log of absolute value of y is equal to 3 times the natural log of the absolute value of x plus c. So we got ln's on both sides here. So at this point, I have found my antiderivatives, and I'm going to go ahead and try to find my c value. And the way that I find my c value is to use my initial condition. So this is saying that when x is 1, y is e. So I'm going to plug the e in for y. And I'm going to plug the 1 in for x. And now I need to evaluate. So the absolute value of e, of course, is e, and ln of e is 1. And natural log of 1 is 0, and 3 times 0 is 0. So I'm getting c equals 1. So then I'm going to go back here, and I'm going to write natural log of absolute value of y equals 3 natural log of absolute value of x. And I know my c value now is 1. So then my final steps are going to be to try to get the y by itself. So I'm going to go e to both sides. When I do that, I end up with absolute value of y equals e to the 3 natural log absolute value of x plus 1. Keep in mind that plus 1 needs to be in the exponent. And then finally, I need to evaluate my absolute value. So once again, I'm going to look back over to here on this step when I applied my initial condition. We can see that the e is already positive, and so the evaluation using the absolute values would not really have an effect. Since the input's already positive, it's not going to be changing, the absolute values will not be changing the sign of the input. And so as I evaluate absolute value of y, we will, again, just like number 4, we will take the positive side of this. So y equals e to the 3 ln of absolute value of x plus 1. That would be our particular solution, there we go, for this particular differential equation. All right, we're going to look at our final example here on our video, number 6. And number 6 has the distinction of being one of the very lowest scoring AP free response questions of all time. And so I encourage you all to look this one over and of course do your best. Some of the questions are pretty challenging. I'm pretty sure you can do many, if not all of them, but I want you to give it a shot. Go ahead and pause the video. I'll tell you what, let's piece this out one by one. So why don't we just try A right now, and once you're done with A, let's push play again, and we can see what the solution should be. All right, so we're just going to be talking about letter A for now. So letter A says use the line tangent to the graph of W at t equals 0 to approximate the amount of solid waste the landfill contains at the end of the first 3 months. So in order to use the tangent line approximation, we need to actually have the tangent line approximation. So let's find that first. Hopefully you remember, to find the equation of a tangent line, we need to have the point of tangency as well as the slope of the tangent line. And they do mention the point of tangency right here. They say at t equals 0. So I'd say that my point of tangency is that when t equals 0, w is 1400. And where I am getting that from is right up here. It says, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. So at the beginning, sounds like t equals 0, and 1,400 tons of solid waste would be the w value when t is 0. That's my point of tangency. Now I need to find the slope of the tangent line, and I'm going to use my dw dt to help me find that. And so I'm going to calculate dw dt when t is 0, and that's going to give me 1/25 times 1,400 minus 300, and I'm getting that 1,400 from the fact that when t is 0, w is 1,400. All right, so then I'm going to finish this off by evaluating. Of course, 1,400 minus 300 is 1,100, and 1,100 divided by 25 is 44. So that means my slope is 44. So the equation of my tangent line, I could do maybe like a point slope idea here. We could even use y's and x's. We could use w's and t's, I suppose, but I think I'm going to go with y's and x's, knowing that y is an approximation for w and x stands for t. So I'm going to say y minus 1,400 equals 44 times x minus 0. And of course I could clean that up a little bit if I wanted to put it into slope-intercept form. It would be y equals 44x plus 1,400. Okay, so now it wants us to use that tangent line approximation to approximate the amount of solid waste when t is 1/4. So I'm going to say y equals 44 times 1/4 plus 1,400, and that would equal 1,411, I believe, and that would be approximately equal to w of 1/4. 1,411 tons, I guess it would be, of waste. All right, so that was a pretty challenging question. Let's see what we can do with letter B. Letter B says find the second derivative in terms of w, then use that second derivative to determine whether what we got in part A is an underestimate or an overestimate of the amount of solid waste at t equals 1/4. So go ahead, pause the video, give this one a shot. All right, so let's go ahead and find d squared w over dt squared. Let's keep in mind what that means. This means to do ddt of dw dt. And it's important that we note that. You might be tempted to do ddw of dw dt, and that's something you could do, but it's not what this is asking for. So it's really important we understand we're going to be differentiating with respect to time in order to get this second derivative. So what I'm going to do is I'm going to say dw dt is equal to 1/25 w minus 300. I think what I'm going to do is go ahead and distribute that 1/25. That might make this a little bit easier. So I'm going to say dw dt equals 1/25 w minus, and then 300 divided by 25, of course, is 12. So we end up with something like this. And now we are going to do ddt to that. So as I do that, I'm going to get d squared w over dt squared, and that was the idea. That's what we're looking for. This would equal 1/25 times dw dt. Again, using the chain rule here, we're doing ddt of everything. Since we're doing ddt of a w, then the chain rule factor is going to show up. Now this did ask us to find d squared w over dt squared in terms of w. And so right now it's not in terms of w, so I need to do a little substitution for this. I just need to recognize that dw dt is what I originally started with. So what I can then write, this is the first derivative in other words, I can write d squared w over dt squared equals 1/25 times 1/25 W minus 300. I'm just replacing this with this because I know they're equal, because that's actually what I started out with. So then I'm supposed to figure out, using the second derivative, if my estimate from A is too high or too low. Of course, this is the second derivative, so that's going to allow me to kind of make that connection. And what I'm going to do is use the domain for W to kind of help with this. In the question stem, it says that W starts at 1400 and W is an increasing function. And so what I can basically say here is something like this: because W is going to be greater than or equal to 1400, the second derivative will always be greater than 0, right? That makes sense. 1400 minus, oh, I lost a 0 there. 300, there we go. 1400 minus 300 will always be, bigger than 0, and W is only going to get bigger. So since the second derivative is always positive, the approximation that we found, let's think this through. If the second derivative is positive, that means W is concave up, and so that means that any approximations we find are going to be too low. So we can say the approximation we found is too low, or it's an under approximation or underestimate of what the actual amount is. All right, so we got one left, and that is part C. So part C is the part that really applies to Chapter 6 here. Notice the familiar language. It says find the particular solution to the differential equations right there, with the initial condition W of 0 equals 1400. Of course, that being true to form, with the initial amount of solid waste being 1400 tons. So certainly want you to try this on your own. Feel free to pause the video at this point and push play when you're ready to see the solution. All right, so of course our first step is to separate the variables. I'm going to separate the variables by doing a little division and multiplication. We're going to get dW over W minus 300 is equal to 1/25 dt. So at this point the variables are separated, and I would in all likelihood earn a point. If I didn't put this step, I would be earning probably no points on this problem. All right, so the next thing I need to do here is find my antiderivatives. So I'm going to do that on both sides. On the left side, I'm going to get natural log of absolute value of W minus 300 is equal to 1/25 t plus c. At this point, I found my antiderivatives, and so I'm going to go ahead and try to find my c using my initial condition. Of course, that's right here. This is saying that when t is 0, W is 1400. So it's going to be natural log of absolute value 1400 minus 300 is equal to 1/25 of 0 plus c. So of course we get just c on the right side, and on the left side we're going to get natural log of 1100. All right, so then I can just plug that back in for the c and try to solve for W. So it'll be ln of absolute value of W minus 300 equals 1/25 t plus natural log of 1100. My final couple of steps will involve solving for W, so I'm going to go e to both sides. When I do e to both sides, I'm going to get absolute value of W minus 300 is equal to e to the 1/25 t plus natural log of 1100. And then finally, I need to evaluate my absolute values. Remember back here when we used our initial condition, remember that we just got 1400 minus 300 is 1100. Of course, that's already positive. And so the absolute value of a positive number is just a positive number. So in other words, we didn't have to find the opposite of the input to evaluate the absolute value. And so as I evaluate these absolute values based on, of course, the initial condition that really the domain for W, I'll be doing the same thing. So the absolute value of W minus 300 would simply just be W minus 300. And that equals the same thing over here on the right. And my final step would be then to add to both sides, and I would finally get W equals e to the 125th t plus ln of 1100, and then plus 300 to be back down at the base level. There is a little bit of simplification you could do here. You want with the the ln of 1100 and the e, but at this point you've written the correct answer, and there's no need really to go beyond that. So that would be our particular solution for this differential equation. I hope you were successful. If you were, then you certainly were more successful than the vast majority of the test takers on this particular year. I think this was from 2011. So I hope that went well for you. Look forward to seeing you guys when I get back. Next time when we get back, we'll be looking at logistic growth. Be sure you look ahead at that and be ready to go with that when I see you tomorrow. Hope you have a great day.